As you look out into the vastness of space, it's impossible not to be struck by the dazzling beauty of billions of stars. Each one appears to ask silently a question that has fascinated humanity for generations. Are we alone in the universe? This ancient mystery has inspired the imagination and curiosity of scientists, philosophers, and dreamers for centuries. Our desire to know our position in the universe is as old as civilization, and it continues to move us to look up in wonder and hope. In an aggressive effort to assist in answering that question, researchers recently launched into space a game-altering instrument, the James Webb Space Telescope, JWST. This incredible device is like a supercharged magnifying glass, giving unprecedented clarity in gazing at far-off planets and objects. JWST, though, is far more than a novel telescope. It is a giant leap forward in our capacity to examine space, allowing us to observe the universe in manners never before conceivable. One of the most thrilling achievements of JWST so far has been the discovery and observation of a fascinating exoplanet called K218b. The planet rapidly caught the attention of the scientific community, and for good reason. K218b is no ordinary planet. It has properties that make it a particularly interesting subject for study. Most provocative is the detection of water vapor in its atmosphere, a discovery with serious implications for the potential for life. Since water is a requirement for life as we know it, scientists began to wonder, could K218b be hospitable to life after all? Adding to the enigma, scientists also found on K218b a molecule that is commonly associated with life processes on Earth. This finding sparked even more enthusiasm with the possibility that life, at least microbial, may exist beyond our planet. Is this the breakthrough we've been searching for all these years? Do we finally have proof of extraterrestrial life? In this detailed analysis, we'll discover K218b in depth, talk about the challenges scientists face in researching it, and ponder what this would do to our understanding of the universe. K218b is super-Earth, more precisely a sub-Neptune, approximately 120 light-years from Earth. That means it is bigger than our planet but smaller than Neptune, a sort of planetary entity for which we have no immediate equivalent in our own solar system. These facts alone about K218b are enough to make it worth exploring. Researchers tend to draw on rocky planets like Earth and Mars, and gas giants like Jupiter and Saturn to inform exoplanet theories. Sub-Neptunes like K218b are not typical, though, and present a puzzle without a clear analog. K218b is noteworthy because it orbits within the habitable zone of its host star, which is a red dwarf star known as K218. The habitable zone is the Goldilocks area where temperatures might allow for liquid water. While Earth is about 1 astronomical unit AU away from the Sun, K218b is much closer to its star, at a close 18 cents, even closer than Mercury is to the Sun. A year on K218b lasts only 13 Earth days. Its red dwarf star emits much less heat than our Sun, so even at this distance, the surface of K218b isn't completely charred. In fact, this has enabled scientists to detect water vapor traces in the atmosphere, a promising sign that the planet is capable of sustaining life. Things started getting exciting when biological signatures were found in the atmosphere of the planet. Methane, which also breaks down quickly in sunlight, was detected along with carbon dioxide. Yet what drew special notice was the presence of dimethyl sulfide, DMS, a molecule that is not typically present in Earth's environment unless there is life. On our planet, DMS is a byproduct created by microbes in the oceans and thus is a robust biosignature. Its existence on K218b suggests the potential for biological activity occurring far outside of our planet. This is especially fascinating because red dwarf stars are typically thought to be too volatile to support life, emitting intense radiation. And yet here's K218b, circling such a star, still with the indications that it may be habitable. To support liquid water, K218b must be in the right temperature zone, not too hot and not too cold. If it has a stable, hydrogen-rich atmosphere, scientists believe it may have Earth-like surface temperatures, though slightly warmer. The thick atmosphere may also trap heat, reducing the chances of water evaporation. This feature is significant because surface water is considered to be one of the primary indicators of a planet's ability to harbor life. Astrophysicist Niku Madhusudan, renowned for his research into space biology, introduced a new term in a recent astrophysical journal paper, Hycean planets, short for hydrogen-rich exoplanets in the cloud. These sub-Neptune planets, like K218b, are cloaked in thick hydrogen atmospheres and could be dramatically different from anything we've encountered. Hycean planets might be up to 10 times Earth's mass and twice its size. Rather than baking hells, they can have massive layers of water, even 90% of their mass, protected by insulating atmospheres. That renders them especially intriguing in the search for life. What is even more fascinating about Hycean worlds is that they are capable of hosting simple microbial life. These ocean planets, which are ubiquitous throughout the universe, offer an interesting new batch of planets to study. However, even with the James Webb Space Telescope's advanced technology, studying these planets at close range remains difficult. It required a highly timely observation to get data from K218b. Scientists waited for K218b to pass in front of its star, a transit. As that occurred, JWST measured starlight as it traveled through the planet's atmosphere. The light carries an imprint of what's in the atmosphere. By breaking it down into individual wavelengths like a prism splitting white light into a rainbow, scientists could see which wavelengths were absorbed. Wavelengths that are missing point to chemicals in the atmosphere, and from this scientists can draw a clearer picture of the planet's atmosphere. This method of atmospheric analysis is one of the most promising techniques of extraterrestrial life detection available today. The fact that JWST is able to detect and analyze these signatures shows how far our technology has progressed, and how close we may be to getting an answer to the greatest question of humanity. In short, the discovery of K218b has opened a new chapter in the search for extraterrestrial life. With signs of water vapor, potential biological molecules, and a unique combination of atmospheric conditions, it's one of the most hopeful exoplanets that have been found. The fact that life might exist on a planet orbiting a distant red dwarf challenges everything we once knew about habitability. As our tools grow stronger and our quest more ambitious, the universe continues to surprise us, and the mystery of life in the universe remains more alive than ever. The fact that K218b is orbiting a red dwarf star, notorious for its intense radiation and generally considered not to be habitable, makes this discovery all the more intriguing. To find out more about the planet, it is worth noting that for K218b to contain liquid water, it would have to be within the habitable zone of its star, where temperatures are neither too hot nor too cold. If it has a stable atmosphere, temperatures on K218b would be quite like those in Earth's environment. However, its predominantly hydrogen atmosphere could slightly warm oceans. Because of its proximity to the host star, K218b could also receive a thick atmosphere that traps heat, preventing surface water from evaporating. That is a significant impediment because surface water is considered a potential differentiating characteristic for exoplanets like K218b. Tools. Astrophysicist Niku Madhusudan, who has studied DMS in space, proposed a new category of exoplanets in a fascinating paper in the Astrophysical Journal. He proposed the term Hycean, hydrogen-rich exoplanets in the cloud, to refer to sub-Neptunes like K218 be enveloped in dense hydrogen-rich atmospheres. Madhusudan's planets could be completely alien to anything we've seen until now. Hycean worlds would be able to have 10 times the mass of Earth and double radii. Instead of being hothouse deserts, they would encompass a titanic layer of water and may compose up to 90% of the mass of the planet. These dense atmospheres could trap heat from a star, allowing liquid water to exist over a much broader range of distances from the star than on rocky planets like Earth. What is unique about Hycean planets like K218b is that they hold the potential of fundamental microbial life. If such planets exist, then they would have a vast ocean that could contain the constituents of life. Their relative omnipresence in the universe renders them prime candidates in the search for life beyond the Earth. Even with the advanced technology of the James Webb Space Telescope, it is difficult to see the oceanic features of K218b. In order to unlock the mysteries of this distant world, there had to be a well-designed observation. Scientists needed to observe K218b during transit, a celestial event where a planet passes between its star and Earth. When K218b passed through transit, the JWST captured the light as it passed through K218b's atmosphere. The beauty of this technique is the unique fingerprint that the starlight carries. From the study of this fingerprint, scientists can determine the chemical composition of the planet's atmosphere. This allows them to ascertain which molecules are there and gather information about the planet's environment. The light is broken down into its individual wavelengths, just like a prism cuts up white light into a spectrum. If certain wavelengths are missing from the final spectrum, this provides important information about the chemical composition of the distant world. This method is a valuable resource for scientists since it enables them to develop a general picture of the planet's environment. The ability of the JWST to study the atmosphere of K218b is a testament to how much technology has advanced us in the knowledge of the universe at an even higher level than before. K218b was discovered by the James Webb Space Telescope and is a dawn of new horizons for the possibility of discovering life beyond our planet. The presence of water vapor, biological signals, and the aberrant atmospheric conditions of the world make it a promising target for future study. The potential for life on K218b challenges our current understanding of the cosmos and pushes the boundaries of what we know about the nature of habitable worlds.